Hey folks, good afternoon or morning, everyone. Welcome back to Algebra 1. I hope you had a good productive Wednesday and that your Thursday is going great so far. We are going to finish our lesson on using quadratic equations to solve real world problems. We're going to look at a very interesting little application here. It will work two examples of this, and then you'll have the rest of class to work a couple other examples on your own. This is going to be a little bit different than what we've done in the past. So be sure you're paying super close attention as we work through these two examples. All right, let's go ahead and let's get started for today. We are going to start with problem number 6 on your piece of paper. We are told you have 292 feet of fencing to enclose a rectangular region to protect the sea turtles at the beach. Find the dimensions of the rectangle that maximize the enclosed area. Okay. So if you're looking at this problem and you're thinking, there's no equation. What are we going to do? This is a little bit different, but we can actually solve it using some of our similar strategies. Let's go ahead and let's get started. Whenever you're given a problem like this that talks about a shape, let's draw that shape. We're looking at a rectangular region. So on your paper, I would just draw a little rectangle. And then we're going to go from here. Okay. All we are told is that we have 292 feet of fencing. So as we travel around this rectangle, we need to use 292 feet. However, here's the tricky part. They don't tell us how big the sides are, right? We kind of have to guess, or we have to have a way to solve for it. What I would recommend is, since we don't know the sides, let's just call one of our sides X. Cool thing about rectangles, the sides that are opposite each other have the same measure. So my other side can also be found by putting X. Okay, we got 2 of our 4 sides, right? We're halfway there. The last 2 takes a little bit of trickery to find. So what I'm thinking is, let's look at an equation we know. Hopefully in middle school, you talked about perimeter. Perimeter is the distance outside a shape. And for a rectangle, we have an equation for it. Perimeter equals 2 length plus 2W. Now, if we look at this equation, P equals 2 length plus 2W, we actually have some things we know already. We know that the total amount of fencing we have is 292 feet. Whatever our rectangle size is, it has to be covered by 292 feet. So we can fill in 292 for P. We also know one of our measurements, we gave the variable X. 292 equals 2. Let's say our length is X. So we can replace our L with X. And we don't know W. We're going to employ a little bit of math trickery on this, a little bit of tomfoolery here. If we wanted to get W by itself, how could we do that? The first thing we would do is we would subtract 2x on both sides of my equation. Those are going to cancel. My 292 doesn't have an x. So we would actually write this as negative 2x plus 292 equals 2w. Now, to get rid of the 2 in front of the w, we're going to divide everything by 2. This is going to give us w equals negative 2 divided by 2. It's going to be negative 1x plus 292 divided by 2. Putting that into a calculator, 292 divided by 2 give you 146. Negative 1x plus 146. So now we can make that note. Our width is negative 1x plus 146. Okay. This part can be tricky for some students. I totally get it. When I looked at this problem for the first time, I had to try it a bunch of different ways before I found one that made sense. Now, however, we have another equation we can fill in. We can fill this in on both sides of our on the last sides of our rectangle. Okay. There's another thing we do with shapes that's going to be very helpful for us here, and that would be area. Perimeter is the distance outside a shape. Area is the stuff inside. And for a rectangle, area equals length times width. Okay. Let's try and write an area equation. We knew area is equal to length times width. And we know our length is x and our width is negative 1x plus 146. We can solve that. We can do this using the distributive property, distributing our x to both terms. If you think back to a few weeks ago, right at the beginning of the quarter, when we take x times x, this is going to become negative 1x squared plus 146x. And that's what our area equals. Now that we're here, notice we have a quadratic equation. We have an x squared. So our thought is, let's find the vertex. Again, we can find the vertex using x equals negative b over 2a. For our problem, our a value is negative 1, and our b value is 146. Plugging those into our formula, x equals negative b over 2a. It's going to be negative 146 over 2 times negative 1. Negative 146 will stay the same up top. 2 times negative 1 is going to give negative 2. And let's put that in the calculator. Negative 146 divided by negative 2 is going to give you x equals 73. X equals 73. Now, we were told we need to find the dimensions, our length and our width. Since x is 73, this tells us that L is going to be 73. Our length is 73 feet. We can also use this to find our width. Width is -1 times 73 plus 146. Taking our x and replacing it with 73. You don't have to do that in your head. Let's do it with a calculator instead. -1 parentheses 73 plus 146. Weird. It'll give you 73 again. Okay. We now know our length and our width. So we can sum it up in a sentence by saying the dimensions would be a length of 73 feet and a width of 73 feet. Okay. I don't know about you, but this seemed like a lot, right? We had to draw diagrams, we had to write many equations. These problems can be a little bit trickier. We're going to work one more example. And in this example, it's going to show us a shortcut that can actually make things a lot better. A different way to work these. At this point, you can go ahead and pause the video. Make sure you have everything written down, and we'll move to the next slide. Okay. Hopefully you've got everything unpaused. Let's move on to our last question, question number 8. We are told a city landlord wants to enclose a rectangular grassy lot that borders his building so that they can create space for a vegetable garden. We have 316 feet of fencing, and we do not fence the side along the building. That's super important. We are looking for the largest area that can be enclosed. Okay, no equation. So let's draw a diagram first. We're looking at a rectangle. But here's the twist. We do not fence the side along the building. So it's almost like one of these sides. We need no material. So really the only 3 sides we're worrying about fencing are these 2 sides and then the long back one. Last time, we gave one of our sides an X. So let's do that again here. I would recommend giving the side that you have 2 of an X. Makes it a little bit easier. And then here's kind of our little trick. Since we don't have to worry about this side down here, we can find this top side by taking our number 316, and we can just take away what we've already used. So in this case, X and X, 316 minus 2X. We can say our length is X, our width is 316 minus 2X. All right, now that we've done all this, let's go to our area equation. Area equals length times width. That equation served us really well last time, since when we were dealing with rectangles. And we're looking for the largest area. So it ties in quite nicely. Let's plug in our values. Length is X. Width is 316 minus 2X. Once we get here, we can apply our distributive property. Multiplying X to both of the pieces inside our parentheses. We're going to get A equals 316x minus 2x. X times x is going to give me to the second. Okay, got an equation. Let's find the vertex. We start by identifying our A, our B, and our C. Be careful on this step. My A value is the number in front of my x squared. What's in front of my x squared here? -2. A lot of people are tempted to take the A value as the first number, but really A is whatever's in front of my x squared. My B value is going to be whatever in front of my x. So in this case, we'll get 316. And my C value, there's nothing. So we're just going to say C equals 0. Let's go to our equation. X equals -b over 2a. It's going to be -316 over 2 times -2. It's going to be -316 over -4. Plug that into the calculator. -316 divided by -4 gives me 79. X equals 79. Okay, so now we know what x is. We know what our length is, but that's not what we're looking for. We're looking for the largest area. And lucky for us, don't we have an equation for area already? We have our area equation right here. So what we can do is we can take our equation, A equals 316x minus 2x squared. We're going to take our x and we're going to replace it with 79, with whatever value we calculated. So this will be 316 times 79 minus 2 times 79 squared. Let's put that calculator to work. 316 times 79. To do the squared, you're going to hit that little button right there. Ooh, but not there. Mr. Onifrio is being a little silly. 316 times 79 minus 2 times 79 squared. Plug that in. And there's your answer. Our area is equal to 12,482 feet. An area is measured in feet squared. Okay, so let's put our answer in a sentence. The max area is 12,482 feet squared. Okay. I know these examples are a little bit trickier than the ones we've been working the past few days. The toughest part is trying to come up with your equations. I still want you to try and give them a shot. You should have everything you need here. But if you need some help, please feel free to send me an email or do what you can, and then we'll talk when I get back. For now, you have the rest of class to work on your last 2 example problems of these, or to work on your dream box. Once you are done with this sheet, please write your name on it and submit a picture on Canvas, or leave your sheet on my desk. Just make sure your name is on it. You have the rest of class to work. Tomorrow will be set aside for you to work on your dream box and any missing note sheets you may have. I will have all of these videos posted to Canvas for you, so you should be able to access them all on your laptop. I hope you have a wonderful rest of your day, and I will see you all fresh on Monday, ready to do some more work. Great job this week, everyone. Have a good day.